Hello friends, in this video let us discuss about the Triac in power electronics. So the Triac is an acronym for triode alternating current. So it is an acronym for triode alternating current where TRI is taken from the triode and A for the alternating and C for the current. So basically your Triac is a bidirectional thyristor with 3 terminals. So it is a bidirectional thyristor with 3 terminals, and it is extensively used for controlling the AC power applications. So putting it in other words, Triac is a 3-terminal AC switch. It's a 3-terminal AC switch which is different from the SCR in the sense that your Triac can conduct in both directions. That is why it is said as bidirectional. So your Triac can conduct in both directions, unlike your SCR. That is, whether you apply the gate signal is a positive or gate signal is negative, the Triac will conduct. So irrespective of the polarity of the gate signal, the Triac will conduct in both directions, unlike your SCR. So in SCR, if you see the structure, the symbol of your SCR, so we are having anode, this is cathode, and this is a gate terminal. So just like this, SCR is a unidirectional device which allows the current to flow in only one direction. So if we observe the switching or the current controlling power of your SCR, so let me draw the plot. If I say this is my input waveform, so the SCR, if I say this is my firing angle, let us say some alpha, so the SCR will control the current flow only in one direction. So only in the positive direction the current flow can be observed in your SCR, and in the negative flow there will be no conduction. So there will be no conduction in the SCR. Now coming to the Triac, so if I draw the waveform like this, and let me say this is my firing angle alpha and this is the firing angle alpha. So the Triac have the control over the positive half cycle, and similarly it also have control over the negative half cycle. So as you use the Triac, we are having the more power utilization with the Triac in the switching applications, whereas with the diode, for the negative half cycle, I do not have any control over my current. Therefore, it is better to use the Triac, or it is an ideal device to use the Triac in AC power switching applications, but generally your Triac is used only for low power AC switching applications, because for high power it causes difficulty in switching problems. We shall discuss what are the difficulties for the high power applications. So basically your Triac is used for switching operations, that is the AC power control in both cycles of an alternating cycle. That means in both halves we are having a control over the current. That means we can control the current in the positive half as well as in the negative half. If you use your SCR, it is a unidirectional device and it has the control over only the one half of cycle. So we have seen that as this Triac is able to control the current in both halves of an alternating cycle, this is effectively used as a AC switch. This is effectively used as a AC switch, and the maximum rating of the Triac available in the market is 16 kilowatts. So 16 kilowatts is the maximum rating of a Triac available in the market. Now coming to the symbol of your Triac, so basically the Triac have 3 terminals, and the 3 terminals are MT1, that is the main terminal 1, main terminal 2, and we are having one is the common gate terminal. So this is the symbol of your Triac. Now discussing about the construction of your Triac. So discussing about the construction of the Triac is equivalent to the 2 thyristors connected in inverse parallel position with the gate terminal taken common. So if I draw 2 thyristors, so let me say this is my one thyristor and here I am having the other thyristor. So they are basically connected in inverse parallel with the gate circuit common. So if this is my gate terminal here and this is my gate terminal here, so they are connected to a common gate terminal. So this is basically your analogy of triac with the two transistors. So here you are having a terminal MT1 and this is the terminal MT2. So the conception is not looks equivalent to the two thyristors connected in inverse parallel with the gate terminal taken common and with the three terminals MT1, MT2 and the gate terminal appearing outside. So basically, this is nothing but a 3-terminal 4-layer bidirectional semiconductor device. So it can be represented like, suppose if I say this is a 4-layer device. So if I say this is my P alternating P type N type material doping N P and this is N and this will be N, this is P and this is N and this is P. So here you are having your MT1 terminal. So this is main terminal T1, or let us say this is T2 or anything as a switch. So this is your main terminal MT1 and the gate terminal is taken from here. So from here you are having a gate terminal. So the gate terminal is taken here. It appears like, so the device has the 4 layers PN for one half of the alternating cycle. So the current flows in PN for the one half of alternating cycle and for the other half it will flow in the NP layers. So basically it is a 4-layer device with 4-layer 3-terminal and bidirectional semiconductor device. So if I say I am having, let me say this is my terminal MT1 and this is the terminal MT2 and this is my gate terminal. So the gate terminal is, if I indicate the layers, so if I indicate this is my P1, this is my N1, this is P2, this is N2, this is N3 and this is N4. So here the gate terminal is connected to both the regions. So it is connected to both the regions P2 and N2. In order to apply the gate signal, it is connected to both the regions P2 and N2 irrespective of the polarity of the gate signal. So either it is positive or it is negative, the gate signal will be applied as the gate terminal is connected to both the regions P2 and N2. And here we do not have any cathode and anode just like in your SCR, because since the thyristor can conduct in both the directions, it is a bilateral device as we can say. So therefore we do not need to indicate it is a bilateral device. Therefore we do not need to indicate whether it is an anode or cathode, because it can conduct in both the directions irrespective of the gate signal polarity. So it has 3 main terminals. So one is the MT2 indicated by MT2, MT1 and the G. So basically the triac has 4 modes of operations. So it has 4 modes of operations. So basically what happens is we can turn on the SCR. We can turn on the SCR in each half of the applied voltage by, that is if we can turn on the SCR in each half of the applied voltage by applying the gate signal. So by applying a gate signal with respect to the main terminal. So with respect to the main terminal we have to apply a gate signal. It may be a positive gate signal or a negative gate signal with respect to the main terminal T1. So we can turn it on 2 ways. We can increase the voltage beyond the forward breakout, that is any breakout, it can conduct in both modes. So if we increase the voltage beyond the breakout voltage, we can turn on our SCR. The other way is around is you can use a triggering circuit, that is a gate triggering circuit, to on your triac, and normally the pulse duration with the gate triggering circuit is 35 microseconds. So for the proper turn on with the proper firing angle, the gate pulse has to be applied for 35 microseconds, and then we will have the proper turn on with the proper firing angle. So now once the gate circuit is turned on, the operation can be explained in 4 modes. So if I say the first mode is my MT2 is positive with respect to the MT1 terminal, that is the main terminal T1, and similarly the gate terminal is also positive with respect to the main terminal T1. So if I say this is the negative terminal of the battery and this is the positive terminal of the battery, therefore the current, the charge carriers, here your IG current will flow from here. So therefore the charge carriers are injected into the P2 layer and the current flows here, as the gate current injects sufficient charge carriers into the P2 layer. So now here if you observe, as MT2 is positive and the gate is also positive with respect to the main terminal T1, that is MT1. So here this will be the forward bias junction and this will be forward bias junction, but whereas your N1P2 will be reverse bias junction. So these charge carriers injected into the P2 layer will break down your reverse bias region and the current starts flowing through the path P1, N1, P2, N3. So this will be the current path once the reverse bias region gets breakdown. Now the second mode is MT2 is positive but your gate is made negative with respect to MT1. So here the gate is made negative and this is made positive. So thereby we are injecting a negative gate current signal is given to the P2 layer. So for this the current will flow from, for this mode the current will flow from the layer P2 to N2. So the current will flow from P2 to N2 layer and the charge carriers injected will break down the reverse bias junction that is formed here at N1P2, and the current in this mode will flow through the layers P1, N1, P2, N2. Now the third mode is MT2 is negative as well as the gate is negative. So when both are negative, so here you see this is negative and the gate is also made negative with respect to the main terminal T1. So therefore this P1 is connected to the negative terminal and here the current will flow from this P2 layer to N2 layer and the N2 layer injects electrons into the P2 layer and this breaks the reverse bias region. So this will be the reverse bias region for the mode 3 and these injected electrons will break down your reverse bias region and the current will flow from P2, N1, P1, N4. So this will be the current direction. So here P2, N1, P1, N4 will be the current direction for the mode 3. Now for the mode 4, MT2 is negative but the gate is made positive. So here this gate is made positive and MT2 is negative with respect to the main terminal T1. So the current will flow from the layer P2 to N3 layer. So that means the electrons will get injected into the P2 layer and this successfully break down the reverse bias junction and the current will flow from taking the same path, that is a P2, N1, P1, N4. So these are basically the 4 modes which are operating in the 4 quadrants. So this will be your first quadrant, this will be second quadrant, this will be third quadrant, this will be fourth quadrant. So all the 4 modes we are basically using only the 2 modes, that is the first mode this mode and this mode. These two modes are only being used. So now if you observe the IV characteristics for your triac, the characteristics of the triac are similar to the SCR, but here the characteristics will also apply for the negative triac voltages. So if I draw the characteristics, so initially it will be in the blocking mode. So in the blocking mode, when the voltage rises beyond the breakover voltage, the current will the current will have a sudden increase, and in the reverse region also there will be a blocking mode, and once the reverse breakdown voltage, or once you increase the voltage beyond the reverse breakdown voltage, the current will increase in this manner. So basically, if you see for the thyristor, you will be having the same characteristics as you observed in thyristor, but here for the negative triac voltage also you will be observing the same characteristics as it is a bidirectional device. So here there is a large increase in the current, and this large increase in the current may damage your triac. So for this reason, it is necessary to use a external resistance connected to it to limit the high rise in the current. To limit the high rise in the current, we need to use an external resistor, and the firing can be provided to the triac by proper gate signal with proper firing angle. The proper firing angle provided by the proper gate signal, and this proper gate signal can be obtained from the gate triggering circuits. So the diac can be used for triggering the gate pulse of your triac, and the triac with the diac combination can be called as the quadrac. So if I draw it here, so if I say this is my diac, and if I connect one terminal to the gate terminal of my, so if I say here is my gate terminal, so if I connect one terminal to the diac, so this combination is called as the quadrac combination, where the diac is connected in series with the triac for triggering or for getting gate pulse from the diac. So basically this combination is also used to prevent the asymmetrical switching occurring due to the triac. That is the main disadvantage is asymmetrical switching taking place due to the triac in the AC power switching applications. So now coming to the disadvantages and advantages. So the advantage of this triac is, so it can be triggered from both polarity of the gate signal, so positive polarity and the negative polarity. And the second advantage is it needs only a single heat sink of slightly larger size compared to two smaller heat sinks required for the SCR. The third advantage you are having is it requires only a single fuse protection. So it requires a single heat sink, single fuse protection, and a safe breakdown can be obtained in either positive or negative voltages. So safe breakdown can be observed in either polarity of the voltages. So these are the advantages. Now coming to the disadvantage, the main disadvantage of the triac is it gives a asymmetrical switching, and due to asymmetrical switching, the circuit is susceptible to electromagnetic interference. It will be susceptible to electromagnetic interference, and it will also give rise to harmonics. And the other disadvantages are, so here we should be extremely careful with the gate signal, because it can be triggered with the positive gate signal as well as negative gate signal, and these triac circuits are less reliable compared to the SCR, and these have low dV by dt ratings, and the power ratings of your triac are also less compared to the SCR. So the applications include control circuits and light dimmer circuits, and as well as in AC power control. with the combination of diac and triac. So this is all about the triac construction, operation, characteristics and the applications. I hope you understood well. Please subscribe to the channel. Thank you.